Okay, so the weight of radioactive substance remaining after T years is given by W equals 1,000 times 2 to the power of negative 0.04 T grams. So question B, which is the question that we're going to be attempting, says write a function for T in terms of W. So we just have to rearrange the equation W equals 1,000 times 2 to the power of negative 0.04 T so that T is a subject. So let's start off by dividing each side by 1,000. That gives us W over 1,000 equals 2 to the power of negative 0.04 T. And now we can just express this like a logarithm. So if we take the logarithm of base 2 of both sides, we get log base 2 W over 1,000, which is equal to log base 2 to the power of negative 0.04 T. And if we just take this part and simplify that down, because we can, it becomes negative 0.04 T times log base 2 as you bring the power down, which is just equal to negative 0.04 T. So what we essentially have is log base 2 W over 1,000 is equal to negative 0.04 T. And all we have to do is divide both sides by negative 0.04 to get what T is. So T is equal to log base 2 W over 1,000 divided by negative 0.04. So that's what we would use in the next two parts. Let's move on to part C of this problem. So part C asks, hence find the time required for the weight to reach, so the first part is 20 grams. So all we have to do is substitute W as 20 and we can find the time. So T is equal to log base 2 20 over 1,000 over negative 0.04. Now what we'll actually need to do is change the base of log base 220 over 1,000, because when we're using the green calculator or the TI Inspire calculator, we need to be able to use log base 10. So let's just write down what we have and change the base. Well, we can simplify this further just to make it log. And then 20 over 1,000 is 1 over 50. So that's just log 1 over 50, which is equal to log base 1 minus log base 250, which is equal to, so log base 1 is actually just 0, so we actually just have log base 250, negative log base 250. Now, writing log base 250 is just negative log 50 over log 2. And that's equal to, so let's just write log 50 divided by log 2. And if we negate that, that becomes negative 5.6439 ... So T is equal to negative 5.6439 over negative 0.04, which is equal to roughly 141 years. So that's for part 1 of question C. Now let's just look at part 2. Hence, find the time required for the weight to reach 0.001 grams. So let's just substitute our value of W as 0.001 into our original equation. So T is equal to log base 2 0.001 over 1,000 divided by negative 0.04. And using the change of base rule, we know log base 2 0.001 over 1,000 is just log 0.001 over 1,000 divided by log 2 all over negative 0.04. And that's equal to, so then we can just evaluate the numerator, which gives us, so negative 6 over log 2 over negative 0.04. And that's equal to let me just evaluate that. That gives us roughly 498.29 years, which we can round to 498 years. So obviously that's a really long length of time, but keep in mind this is a radioactive substance which does take a long time to decay, so if you get a large answer, don't be too worried about that. So part B, we've got this equation. Part C is 141 years, and part 2 of C is 498 years.